And then since 2012, after you'd stepped down as Codes Director, and Bruce Gemmell is the current director, you've held the position of Distinguished Professor at the University of Tasmania. So you spent your career, you built your career on the basis of work on base metal deposits, specifically VHMS and SEDEX, and you then mentioned you expanded into other sediment basin hosted deposits, specifically sediment hosted gold deposits.
Yes, that's been fairly controversial too.
But would you like to say what you think of the great outstanding questions that your group and others will be addressing, and we can look for the results over the next decade?
Yes, the reason I got into sediment hosted gold was it was a number of events that occurred fortuitously, and the opportunity to go to Russia to visit the Suko log deposit, which is one of the biggest sediment hosted deposits on the planet. And that was organised by my very good friend Valery Mashlenikov, who's just been here at our SEG meeting. And that made me realise that the genesis of these big sediment hosted deposits was not well understood. Although they've been thrown into the orogenic bag, they're not classic orogenic deposits. So that started us working. We published a paper in Economic Geology in 2007 on Suko log with a new genetic model for how it formed that became quite controversial. We moved away from the orogenic model and went for a model on the importance of source rocks in gold formation. It actually, when you go back through the Russian literature, it was an idea that the Russians had quite some time ago, but they ditched the idea for what they thought were the more progressive Western ideas. I think they made a mistake. They should have stuck with their own ideas because it's become obvious that carbonaceous shales are a really important source rock for gold. And then in 2009 we wrote that up as a paper that won the B.J. Skinner Award.
For the best paper in economic geology.
Yeah, and that's been proven, I suppose, partly by the fact that it was the most cited paper for the year. So I'm very proud of that paper, which again was a team effort that involved our Russian colleagues because, again, they think differently about ore deposits, and bringing their line of thinking in with our line of thinking led to a model that was very scientific and very robust. And I'm very proud of that, and we're continuing to develop that model, but we've now, through technological advances that have been made in our laboratory, and that's because we have some really top geochemists who have set up laser ablation ICP facilities. It's run by Leonid Danyashetsky, another Russian from the University of Moscow, and that team's done a fantastic job. So we've now got 4 laser ablation ICP-MS units running in our labs full time. Half of them are working on industry-related problems, mainly related to geometallurgy and gold deportment, and the other half on more academic issues. But having that equipment has allowed us to look at the chemistry of pyrite in great detail from an ore deposit perspective. But a couple of years ago, it became obvious to me, it was one of these light bulb moments where you're sitting listening to someone talk about the ocean, and I suddenly realised that if we analysed marine pyrite, sedimentary pyrite, through time, we could reconstruct the trace element chemistry of the ocean through time.
So this is how you then moved into your next phase of research, i.e. ocean chemistry.
Yes, that's right.